Exploratory Factor Analysis, EFA. EFA is a statistical method used to identify underlying latent factors from a set of observed variables. It is mainly used in the early stages of research when the factor structure is not yet known. In simple terms, EFA lets the data reveal how many hidden factors exist and which variables belong to each factor. It works by examining patterns of correlations. Variables that are highly correlated are grouped into the same factor because they likely measure the same underlying construct. EFA is exploratory, meaning no predefined model is being tested. EFA is data-driven, bottom-up, and follows a deductive approach. EFA serves three main purposes. 1. It helps uncover hidden constructs that explain patterns of correlation among observed variables. 2. It reduces many observed variables, for example, survey items, into a smaller number of meaningful factors. 3. Explore factor structure by showing how variables group and which items load onto which factors when the structure is not known. When to use EFA. We use EFA in the early stages of research when our goal is discovery. When we don't have a strong prior theory about how our variables relate. When we are developing a new measurement scale and need to see how many latent factors naturally emerge from the data. Confirmatory Factor Analysis, CFA. CFA is a statistical method used to test whether a set of observed variables, like survey questions, accurately reflects a specific theoretical concept. Unlike EFA, which explores the factor structure, CFA is used when the researcher has specific expectations about how many factors exist and which survey items should load onto each factor. In simple words, CFA is used when you already know what factors should exist and which items belong to which factor, and you want to confirm whether your data supports that structure. It is about confirming a theory-driven factor structure. Why or when we use CFA? The primary purpose of CFA is theory testing. We use it to validate that a predefined relationship between observed indicators and latent constructs actually exists in our data. It is essential for proving measurement validity and ensuring our model is statistically sound. More specifically, CFA is used to 1. Confirm a theoretical measurement model. Test whether observed variables load onto the expected latent factors. 2. Evaluate model fit. Determine how well the data support the hypothesized structure. 3. Assess construct validity. CFA is the gold standard for proving construct validity. It helps you confirm. Convergent validity. Do the items that are supposed to measure the same thing actually correlate strongly? Discriminant validity. Are the different latent factors, for example, satisfaction versus loyalty, truly distinct, or are they overlapping too much? 4. Test a hypothesis. To confirm whether a hypothesized factor structure is a good fit for the data. 5. Validate a scale. To assess the validity and reliability of a measurement instrument. Differences between EFA and CFA. The differences between EFA and CFA can be broken down into three key areas: their overall purpose, their logical approach, and the stage of research in which they are used. Purpose: discovering versus testing. EFA is about discovery. You use it to find hidden patterns and latent structures in your data when you aren't sure how the variables relate. CFA is about testing. You already have a predefined factor structure based on theory, and you are checking to see if your data actually fits that specific map. Approach: data-driven versus theory-driven. EFA follows an inductive approach. It is bottom-up and data-driven, meaning you let the data tell you what the factors are. CFA follows a deductive approach. It is top-down and theory-driven, meaning you start with a hypothesis and use the data to confirm it. Stage of research. Building versus validating. EFA is for the early stages of research. It's used for theory development and when you are creating new measurement scales. CFA is for the later stages. It is used to validate existing theories or to prove that a scale developed in one study works just as well in a new population. In summary, EFA is exploratory and data-driven. We use it in the early stages of research to discover hidden structures. On the other hand, CFA is confirmatory and theory-driven. It's used later in the process to test and validate whether our data actually fits an established theoretical model.